Good afternoon, grade 12s, and welcome to our session for telematics for mathematics this afternoon. My name is Eleanor Splinter, and I hope that you're going to enjoy the session with me. This afternoon, we'd like to firstly welcome all the schools who are logged in. There are some students that have sent me messages before 3 o'clock already saying, "Ma'am, we're sitting in our telematics center ready for the mathematics lesson," and that is absolutely awesome. School is out. You could have gone home, but you preferred to come and listen to the telematics lesson, and that is dedication. Remember, hard work, especially in mathematics, breeds success. The more you put in, the more you're going to get out. And also, remember, mathematics is just practice, practice, practice. I want to start off today by saying that as a maths teacher, I am experiencing this more and more. It is not your clever students who are getting the high marks. It is the hard-working, determined students who are achieving excellent results. And I want to encourage every student who is tuned in this afternoon that with hard work, you will be successful. So what is our session on this afternoon? Just before I start, here's a few students that said, "Ma'am, can you just say what our names are?" And I'm just going to quickly say it's Nkosi Kona, Lithemba, Ayane, and Imslanshla. That is absolutely perfect. Welcome, everybody. And our session this afternoon is on calculus. Now, if you look in your calculus notebooks, you will see that our session is specifically going to be on graphs. So I've prepared this lesson. I'm going to try and get through as many problems as I possibly can. I'm going to first sketch a calculus graph. Then we're going to do interpretation questions. So take out your pencils, have your books ready. And if you don't have your booklet with you, it's okay. You can take my questions down. So no looking around, focus, and remember, when we leave the session, then I would like you to know a bit more than when we started. Okay, let's look at our first question. I made my heading calculus graphs, and we're going to start with example number 1. And it is given that f of x is equal to 2x cubed. The cube already tells you that you're going to be working with a cubic graph, negative x squared, negative 4x plus 3. So the first question says that I have to show that x minus 1 is a factor of f of x. So if you are at your schools and you see this question, you can already do it. I'm sure most of you know what to do. So I want to show that it is a factor. Now remember, everybody, 2 is a factor of 10 because it divides into 10, leaving no remainder. Your remainder is 0. So when I substitute in a value for x, I want to get a remainder of 0. So the first thing that you're going to do is x minus 1 is equal to 0. So you're not going to substitute in the negative 1, grade 12s. You're going to substitute in positive 1. So when I substitute in my positive 1 into the place of x, if I'm substituting, I put it in a bracket. 4 multiplied by 1 plus 3, that gives you 2 plus 3 minus 5. So 5 minus 5 gives me 0. Your remainder is equal to 0, which means that x minus 1 is a factor. So say, for instance, I had x plus 2. I have to prove that x plus 2 is a factor. What are you going to substitute? You won't substitute the positive 2. You are going to substitute negative 2. If your answer comes out to be 0, you know that it is a factor. Our second question says, hence factorize f of x completely. So now I'm looking at the screen. Everybody seems to be okay. Now, if I factorize this completely, it means that I want to determine my x-intercepts. So if you determine your x-intercepts, we have to make y equal to 0. So I'm going to do that. We already know that x minus 1 is a factor. So x minus 1 goes into your first bracket. So now you want to determine this second bracket. When I determine this second bracket, I'm going to first show you the method that I use in my class, but also there are some other methods. I do not want to confuse you. You choose whatever you are good at. I want to get my second bracket, so I'm going to take out a different color. Guys, work out your answers, and if you want to send it to me, please, I can check if you're right. You can even do it before I'm even done. So what I do is, everybody, this x minus 1 is a factor. Now, say, for instance, this x minus 1 wasn't given to you. Remember, we are helping you. We are giving you the first factor. But if we didn't, you must substitute values into the place of x yourself until you get 0. those values that you substitute will be factors of 2, which is plus, minus 1, plus, negative 2, and also plus and minus 3. Guys, I'm now not going to try 5. I'm not going to try 7 because they are not factors of the first and of the last number. So you must choose values and substitute it into the place of x until you get 0. So that will give you the first bracket. Are you all okay so far? Now the second bracket. What I do is I ask myself x multiplied by what gives me 2x cubed. And that would be 2x to the power of 2. Check with me. X multiplied by 2x squared gives me 2x cubed. So that's my first term in my second bracket. Now I do my last term. Negative 1 multiplied by what will give me positive 3? That's negative 3. So check quickly. X times 2x squared gives me 2x cubed. Negative 1 multiplied by negative 3 gives me that positive 3. And now for your middle term. I multiply these two terms together. Negative 1 multiplied by 2x squared gives me negative 2x squared. And I go and check in my original equation how many x squareds I have. I have negative 1x squared. Remember, there is an invisible 1 here. So I have, if I multiply these two together, it gives me negative 2x squared. In my original equation, I have negative 1. I ask myself, Eleanor, is negative 1 on this side or is negative 1 on this side of your number line? It is definitely on this side. Remember? So I ask, how many spaces do I move from negative 2 to negative 1? I have to say negative 2 plus 1 will give me this negative 1x squared. So this plus 1 I'm going to put as my second term. So this is plus 1x there. I hope you understood that completely. I'm going to just do it one more time. That gives me negative 2x squared. I look at my original x squareds. I have negative 1x squareds. So I'm going to jump one space. Negative 2 plus 1 gives me this negative 1. Or is that okay with all of you? Now, for the students who use synthetic division, I know that there are some of your teachers who explain synthetic division. So I'm going to do the following. You take your coefficients of your polynomial. So the coefficients are 2, negative 1, negative 4, and 3. Now you take your number that you substituted into the place of x. What did we substitute originally into the place of x? I substituted 1. Now I put the 1 here. Sometimes I get a little bit confused, so you must tell me here, guys. I'm going to put my 0 down. There's always a 0 that you put there. So you say 2 plus 0 gives you 2. I hope I'm right here. Now you multiply 1 times 2 gives you 2. What is negative 1 plus 2? It gives me 1. And then you multiply 1 multiplied by 1 is 1. Negative 4 plus 1 gives you negative 3. Look how beautifully it ends off. 1 times negative 3 is negative 3, and 3 minus 3 gives you 0. If you don't get that 0 there, you know you did something wrong. Now, what does this represent? This represents what I put into my second bracket. Look, 2x squared plus x plus the 1x minus the 3. Can you see matrix? You can either choose this method or synthetic division or whatever method made sense to you. Whatever you could do, you stick to that. Don't let us confuse you. So I have now got my first factor. You still understand how I got that? Then I factorized. I got my second bracket. And now this is a trinomial. I'm going to factorize my trinomial. That's 2x and x, my 3, my 1, a plus and a minus. Whoa, what do you see? Ma'am, there are 2 brackets that repeats itself. There's a x minus 1 and there's a x minus 1. Matrix, when I see that, I immediately tell myself, if 2 brackets repeat itself, I'm also going to have a turning point at that x-intercept. Remember what I said? Only if 2 brackets repeat itself, you're going to have a turning point there. But these are my x-intercepts matrix. So I have 2 x-intercepts. X is equal to 1 or x is equal to negative 3 over 2. So welcome all the schools again who are logged in. Please work with me and send through your answers. We've done 2 questions so far. We have shown that x minus 1 is a factor, and secondly, we have factorized f of x completely. Matrix, why did you factorize f of x completely? For you wanted to find your x-intercepts. Your x-intercepts were x is equal to 1 or x is equal to negative 3 over 2 from this bracket here. Remember I said, because these 2 brackets repeat themselves, you're also going to have a turning point there. Our next question, are you still all with me, guys? Determine the coordinates of the turning points of f of x. Turning points are also called stationary points. And so if I want to determine the coordinates of the turning points of f of x, we need to know our steps. The first step is to find your derivative. So I take my original function, 2x cubed minus x squared minus 4x plus 3. Step number 1. Now, grade 12, if you want to make a little side note and say, step 1, find the derivative. Step 2, put it equal to 0. Then solve for x. Side notes are lovely. So put that down. You first find your derivative. I think everybody is quite good with finding derivatives. Remember, if you find the derivative, we're not going to use first principles here. They didn't. We don't need that. That's the long method, the 5-mark question, short methods, and the short method we're all so good at. 3 multiplied by 2 gives me 6, and you subtract 1 from the exponent. So that gives you a square. Then 2 multiplied by negative 1 is negative 2x. If you subtract 1 from the 2, it gives you 1. You don't have to put that 1 there. It's an invisible 1. And the derivative of negative 4x is equal to negative 4. What is the derivative of 3? 3 is a constant, and so the derivative is equal to 0. Remember quickly, I always ask my students, you have to understand what you are doing. Remember, this is a constant. And so if I should sketch that, it is a horizontal line looking like that, hey? So what does derivative mean? If somebody asks you, what does derivative mean? It means that you are determining the gradient. And so if I determine the gradient of this line, it's equal to 0. This is a straight line matrix, and negative 4 is in the place of m. So the derivative of negative 4x is equal to negative 4. So everybody, I've determined the derivative. That's step number 1 in your turning points. After you determine your derivative, you need to make your derivative equal to 0. Ma'am, why do I even make my derivative equal to 0? Why? Because if you sketch your turning point, you're going to have a maximum turning point, I'll show you, and a minimum turning point. But at that point, your gradient is equal to 0. Derivative means determining the gradient of a curve at a specific point. So I'm going to put my derivative equal to 0. Step 1, determine your derivative. Step 2, make your derivative equal to 0. Now we're going to factorize. I am definitely going to divide by 2. It makes my life a bit easier. So it's 3x squared minus x minus 2 gives me 0. Open up your brackets matrix and factorize 3x and x. 2 and 1. I'm going to have a negative and a positive there, and you know you are on the right path. Why? Why do you know that you're on the right path? Remember, I told you, if 2 brackets repeat themselves in your x-intercepts, you are going to have a turning point. Look, it's at the same point where my x-intercept is. I hope you remember that. And so the x-coordinate of your one turning point is negative 2 over 3. And the x-coordinate of your other turning point is equal to 1. So remember, a turning point consists of an x-coordinate and a y-coordinate. So how are you going to determine the y-coordinate? Matrix, you're going to take your x-coordinate and substitute it into your original equation. Ma'am, why the original equation? Isn't f of x y? Doesn't f of x replace y? It's the same thing. So whenever you are looking for a y coordinate, you substitute it back into your original equation, not into your derivative, everybody. This is the derivative. So I substitute it into the original equation. I've done this for you already, just to save some time. So y is going to be equal to 2. Just going to show you my substitution quickly. Negative 2 over 3 squared minus 4 times negative 2 over 3 plus 3. When I worked that out, I got an answer of 4,63. So my one turning point is negative 2 over 3 and 4,63. What's your other turning point? 1. Do you even need to go and substitute the 1 again, Matrix? No, ma'am, I did it already. We knew it was a factor. And so the y value is equal to 0. Those are your 2 turning points. Tell me that you're all still okay. Did you also get this at your schools while you were sitting and working this out? Tell me if I'm going too fast. I can always slow down a little bit. But if you're with me, I'll be very happy. So we are on to our next question. What did we do so far? Number 1, we showed that x minus 1 is a factor. Number 2, we found our x-intercepts. And number 3, we found our turning points. And here comes question number 4. Draw a neat sketch graph of f of x, indicating the coordinates of the turning points as well as the x-intercepts. Now, grade 12, I could have asked this question 2 ways. I could have given you the equation and I could just have phrased it, sketch the graph. So if that was the case, these were the steps that you are supposed to follow. You need to get the x-intercepts. You need to get your turning points and your y-intercepts. So it's x-intercept, y-intercept, turning points. But in this question, we helped you. We helped you to get to the sketch. So I am now ready to draw my sketch. And I'm going to draw my y-axis. Draw with me, everybody. Don't chat to your friends. Draw with me. This is quite a popular question in the exam. And that is my x-axis. There's my y-axis, my x-axis, my origin, and here we go. I know what my y-intercept is. What is your y-intercept, grade 12? Your y-intercept is 3. So I'm going to plot my 3. Please, you have no time in an exam to go take your ruler and to physically go 1, 2, 3. I've seen students do that. Then they come out of the exam and they cry, ma'am, I didn't finish my paper. We don't mark your sketch according to scale. It must just be plotted properly. So I'm just going to say, 3 is somewhere here. Don't waste any time. You must do it quickly. So I've got my y-intercept. Guys, what were our x-intercepts now again? Do you remember? It's right in front here. My x-intercepts were 1. So I'm going to plot my 1 here and negative 1.5, more or less there. Can you see I'm doing it quickly, guys? I don't want to waste any time. And your last step was to determine the coordinates of your turning point. I'm just going to push it up so that everybody can see. My turning point is negative 2/3 and 4,63. So negative 2/3 is just slightly before negative 1. You can just guess. And 4,63 is somewhere there, as long as it's above 3a. Do you all agree with me? Negative 2/3 and 4,63 matrix. I always circle my turning points to say that is a turning point, and my other turning point is 1 and 0, and it is also an x-intercept. The graph is a positive graph because I've got a positive in front of my x cube, and so your graph will first go up. If it is negative, your graph will come down. This is if you have a negative in front of x cube. This is if you have a positive in front of x cube. So I'm actually ready to go sketch the graph. I know it cuts the x-axis. I know that it must cut the y-axis. Now this graph is going to turn here and it's going to turn there. You circled your turning points, hence you know I must have a turning point there and a turning point there. Matrix, this turning point can't go up because how are you going to come down to the y-intercept? And so you know this turning point is going to be a maximum turning point, and you are going to connect your dots, and there is your graph. And there you've just sketched a cubic graph. Let's see if we indicated what they asked us. Indicate the x-intercepts. I did, ma'am. And indicate your turning points. We did. And don't forget to also indicate that y-intercept there. What do you think? Do you think that you'll be able to sketch this cubic graph all by yourself? Just follow your steps. I need a factor, my x-intercepts, my y-intercept, and my turning points. Side note for your turning point, find the derivative. Make the derivative equal to 0. And then substitute those x back into the original equation. Matrix, I want to show you something on my graph quickly. So goodness, guys, while I was busy with this graph, these WhatsApp are all just coming through. I am just going to read it quickly. Somebody asked me about the point of inflection. I'm going to do the point of inflection now, Liama, did you get the sketch? That is awesome. And somebody saying from Kensington High School, ma'am, we missed you. Yes, I haven't been on air for a long time, but it's so nice to be with you. Somebody's asking me, ma'am, what do you do when you don't have 2 points that repeat each other? No problem. If you don't have 2 points that repeat each other, you're going to have 3 different x-intercepts, and your turning point won't be an x-intercept. It will just be a different value. But you are still going to follow the steps that I have given you. When you have 2 points that repeat each other, that beautiful lady from Kensington, remember, your turning point is going to be on that x-intercept. That is awesome. And then I just want to say hello to the people there at North Pine. My first house that we bought was in North Pine, and it was just lovely. I hope you're very happy, and everybody looks good, and we can go on. Got your sketches? Beautiful. Guys, I want to show you something. This is a maximum turning point, and this is a minimum turning point. The gradient at this turning point is equal to 0. I want you to do this on your sketch. Tell yourself that the derivative here was equal to 0. The derivative here was equal to 0. So if they give you a derivative graph, you can use that information. All right. And now we buy that guy that was so ahead. He immediately asked me, ma'am, how do I determine the point of inflection? 2 ways. Determine the point of inflection, I wrote this down, and after this question, we're also going to determine the equation of the tangent at a specific point. So we're ready to go. A point of inflection is that point where your concavity of your graph changes. And the point of inflection is always in the middle of your 2 turning points. So I'm going to bring up my graph again. And so there are 2 ways that you can determine the point of inflection. I think if you do have your turning points, the easiest way is just to find the middle of the 2 turning points. I think so. And so the point, write this down, everybody. Point of inflection is always in the middle of your 2 turning points. I have my turning points, and it's here. And so it is going to be, the x-coordinate is going to be -2 over 3 plus the 1 divided by 2. And the y-coordinate is going to be 4,63 plus the 0 divided by 2. Sorry, I shouldn't have put that bracket there. So your point of inflection, I think I worked it out already. Yes, I did. If you do that, you're going to get a 1/6. And this gave me 2,31. It's in the middle of your 2 turning points. Did you get that, guys? But a lot of you do the second derivative, and that's perfect. And you make your second derivative equal to 0. So I've got the first derivative. The first derivative is equal to 6x squared minus 2x minus 4. Step number 2, you find the second derivative. The second derivative is, so you find the derivative again. 2 times 6 gives me 12. Take away 1 from the exponent. The derivative of -2x is equal to -2. You then make your second derivative equal to 0, and you solve for x. Take the 2 across, divided by 12, give you a sixth. Can you see that you get the same answer, Matrix? How do you think you are going to get the y-coordinate? Whenever we're looking for y, we substitute back into our original equation, and I did. We're not going to do that. I'm just going to give the answer, and the answer is 2,31. I hope that you got the point of inflection. Do you know, if you take your graph and you fold it on that point, the one part falls on top of the other part. The point of inflection is the point. It is the position where the concavity of your graph changes. It changes from concave up to concave down, or vice versa. Lots of students say, ma'am, please just give us the method. This concavity business is too difficult, but that is what it means. And so I have the point of inflection, which we got, which is a 1/6 and 2,31. Our next question, I hope I'm not going too fast. Hendra, Kanisi, let me just quickly see what you're asking me. Somebody said, ma'am, we understand you very well, and try not to be so fast, ma'am. I'm okay. I'm going to go a bit slower. And then somebody says, ma'am, we okay? What do you do? Okay, that question I looked at already. Okay, so our questions are all up to date. We've sketched our graph. We found our point of inflection, and now we're going to determine the equation of the tangent at x equal to 2. A tangent We do a lot of tangents in geometry. Do you remember? Also, we do tangents in analytical geometry. Our next session is going to be on geometry, grade 11, geometry, circle geometry. And do you remember those tangent theorems? A tangent and a radius is perpendicular. Or if I don't have a radius, then you look for the angle between a tangent and a chord. Now, tangents we also find in calculus. Now, a tangent here is going to be a straight line. You know that. And what is the equation of a straight line? Y equal to mx plus c. So this is your goal. You need to determine the equation of a tangent. Now start and tell yourself, I have something to work towards. I must get the equation of a tangent. And so I'm going to work out my gradient first, and then I'm going to find c. Now listen very carefully. All of you sitting at your schools, somebody at Lutando, somebody at North Pine, Kensington, all of you, if you want to determine the equation of a tangent, and you know how, go ahead and you can send me your answer and I can see if you are correct. But I'm going to use my logical ability and I'm going to say a tangent is a straight line. So y equal to mx plus c. I need my gradient. Now there's no way that we can go and find the gradient using y2 minus y1 over x2 minus x1. Why not? I don't have 2 points. Remember, tangent cuts your graph at this x equal to 2. So when I want to determine the gradient, just look at logic. Gradient is equal to derivative. Remember, I asked you, what does derivative mean? Derivative means finding the gradient of a curve. So if I am going to find this gradient, my m, I'm going to work out my derivative at a specific point, and that point is 2. So I'm first going to determine my derivative. I have my equation, everybody. You know what the derivative is. I'm quickly going to write down the derivative, not do it again. I get 6x squared minus my 2x minus my 4. We did that already. Now I'm going to substitute in 2. So if the derivative at x equal to 2, substitute in your 2 beautifully. Remember, when you substitute, put it in a bracket. It helps. When I substituted that, I got 16. So my gradient is equal to 16. Remember, gradient is equal to derivative at a specific point. So now I've got my gradient, and it's 16x plus c. So I still need to find the value of c. Remember, you have 1, 2, 3 unknowns in your equation. So if I can put a value into the place of y and a value into the place of x, I can find c. Now you have your x. What is your x? Your x is equal to 2. But I don't have y. Again, you're sitting with the same problem. You need to find y. How do we find y? I can even hear you saying it at your school. Substitute into the original equation for f of x is equal to y. So I did that. I took my original equation. I'm going to write it here for you, everybody. My original equation is this, minus 4x plus 3. I substituted in 2. 4 times 2 plus 3. When I work that out, I got 7, and I'm ready to go. Look, nothing to it, Matrix. You've got this, guys. Substitute y equal to 7 and x equal to 2. And that would give you 7 minus 32, which is equal to negative 25. What is the equation of your tangent? 16x minus 25. How awesome is that? Determine the equation of a tangent. Put your goal down. A tangent is a straight line. Mx plus c is the equation of a straight line. Your derivative is equal to your gradient. Gradient is equal to derivative. I first worked out my derivative, then I substituted in 2 because the tangent occurs at x equal to 2. It gave me m. I told myself that I must still find c, so I'm going to sub in a point. I have x, which is equal to 2. To get y, go to your original equation. You got 7. Sub x equal to 2, y equal to 7, and there you have your equation of your tangent. Matrix, I hope that you're all still okay. I am now going to go to some interpretation questions. So the interpretation questions is slightly more difficult to sketch a graph, to find the point of inflection, to find a tangent. That is all I would say your level 1 to level 2 questions, not a lot of thinking involved, more method. And if you understand your methods, you can get full marks for that section. And we're on to question number 2, and I'd love for you to write this down with me. All right, let's just see. We're all up to date with our WhatsApps. All the questions have been answered. Nobody is okay. Nobody is struggling. I can see that you are okay on the WhatsApp. There's no serious questions. Are you ready to go? Right, look at my next question. Guys, I've seen this question coming up quite a bit, where they give you some properties of a cubic function and you have to sketch a possible graph. Can I quickly read to you? A cubic function, so I know it's x to the power of 3, has the following properties. Write this down, everybody. I'm going to write it down with you, but look at how I'm going to write it down. I'm not going to write it down like they put it in the paper. I'm going to write it down to make it a bit easier for myself. This means f of a half is equal to 0. F of 3 is also equal to 0. Are you writing it down, everybody? And f of negative 1 is also equal to 0. Sometimes when you put it in a line like that, you guys get confused. But if I write it separately, what does this mean? What does this bit of information tell me? It tells me that if x is a half, y is 0. Wait, ma'am, I've got this. Y is 0. So if y is 0, this has to be an x-intercept. Oh my goodness, this is so good. If x is 3, y is 0. This is another x-intercept. If x is negative 1, y is 0. So all 3 of these are x-intercepts. So the student from Kensington High, what can you tell me now? You will not have a turning point here. There's not an x-intercept that repeated itself. So my x-intercepts are a half, 3, and negative 1. I'm going to write that down. X is a half, x is 3, x is negative 1. How did I even know that? If y is 0, this must be an x-intercept. Next bit of information. They tell me that the derivative, oh my goodness, derivative, let me just think quickly, at x equal to 2 is equal to 0. The derivative at x equal to negative a third is also equal to 0. Can we think, when did we make our derivative equal to 0? Can we think? When we found the turning points. Because the gradient at the turning points, look, is equal to 0. The gradient at the turning point is equal to 0. So when we did this, when is the derivative at a specific point equal to 0? When did we do that? When we found our turning points. And writing it like this, is it a bit easier? I can see these are x-intercepts. When did we make the derivative equal to 0? When we found the turning points. I've already got my x-intercepts and I already have my turning points. Do you know what? Now the question says, the function decreases for x an element between negative a third and 2. Oh, that's a little bit difficult for me. I don't understand that. So let me first put down what I have. Okay, I'm a little bit confused. I don't know what to do, ma'am. So can we work with what we have? Draw your y-axis with me. No chatting, no talking. We're all working together. Why? We want to be successful. Mathematics opens doors for us. Got my y, got my x. Right, let's plot. This is an x-intercept. Do you remember? Why? If x is a half, y is 0. I'm going to put that down there. Then that's another x-intercept, which is 3. I'm just putting it more or less on the axis system. I'm not taking time to measure properly. Sketches are not drawn to scale. Sorry, a half is not on the side. It is here. And then this would be, help me, negative 1. Are you happy with what I have? A half, 3, and negative 1. Okay, my negative 1 doesn't look so good. Hey, I bet yours look much better than mine. Right, turning points. Ma'am, I have a turning point at x equal to 2. So 2 is here. So this is going to be a turning point. I'm going to circle it. And I'm going to have an x coordinate of my turning point is negative a third. I have no clue of what the y coordinate of my turning point is. I really don't know. But I do know that this is an x-intercept. I must have a turning point at negative a third, and I must have a turning point at 2, because this is what it says there. If the gradient is equal to 0, it must be a turning point. And now comes the information that I didn't understand so well, but I can maybe visualize it. It says, now use this information above to draw a possible graph. Why do they say possible graph? Because you do not know what the y coordinates of the turning points are. I don't know because I don't have a function f of x to work with to go and take these x values and substitute it into the original equation. I don't have it. That's why they say a possible graph. So now I'm putting my thinking cap on. Oh, goodness, right. Your graph of f must decrease. So that means it must decrease between. So now I'm thinking, okay, if this turning point is here, just look at me quickly. I'm going to make that an x-intercept. It's going to turn here. Oh my goodness, wait. It decreases. Let's see. It passes through that. It must pass through a half. Why must it pass through a half? Because it's an x-intercept. This is a possible graph. And there's another x-intercept. Oh my goodness, let me see if my graph makes sense. X-intercept definitely cuts it there. X-intercept at a half definitely cuts it there. That's an x-intercept at 3. I'm good so far. I do have a turning point at negative a third. So I'm going to make my turning point there. I don't know what the y value is. I have a turning point at negative 2, at plus 2, sorry. I don't know what my y coordinate is. Now I'm going to check if my function decreases between negative a third and 2. The function increases, got a positive gradient. Decreases, yeah, I've got a negative gradient, and then it increases again. This graph definitely decreases between negative a third and 2. Hence, they gave me this information. Matrix, this is a possible graph. Your turning point can be lower than mine. Your turning point can be higher. It doesn't matter because you do not know what the y coordinates of your turning points are. I could not work it out. And that is how you go about those questions. When you get information like this, it is usually the x-intercepts that are given and the turning points that are given. And then they'll give you a little bit of more information where you have to interpret it slightly to see if you can now bring this information together to sketch a possible graph. Let me see how we're doing on the WhatsApps. I can see that you guys still seem okay. You didn't send me any questions with regards to that. And so it looks like you're okay. I hope that you drew that possible graph by yourself before I even drew it. Okay, everybody, I'm looking at our time. And I'm seeing that we have a little bit of time left. It's about 1:45. So that gives me about less than 10 minutes. So I think I'll have time for one more question. So I think I'm going to skip this question that I prepared. And I'm going to try something, a different question. But in your graph book, in your group book that we gave you, there's a question there. I'm quickly going to put it on the screen where it asked you to determine the value of P and Q. So I want to do a question where I have the graph physically, but I maybe just want to help you quickly. I'm not going to do the question, but I might be able to give you the answer, and you can work towards it at home. It says here, the tangent, oh my word, ma'am, tangent, I know that word. Tangent is y equal to mx plus c. The gradient is equal to the derivative. So wait, the tangent to this graph at x equal to 1 has this equation here. So they gave you the tangent. Matrix, can you see why we call this interpretation questions? Because we're not asking you to find the tangent. You are given the equation of the tangent yourself. So you have the tangent, which is 5x minus 8, and it says there that tangent occurs at x equal to 1. The first question is very simple because it just asks you to show that 1 and negative 3 is the point of contact of the tangent to the graph. You're physically just going to substitute your x equal to 1, and you're going to see if you get negative 3. Remember, how do we prove that a point lies on a graph? You just sub in your point. You see if your left is equal to your right. But here comes this question. It asks me to determine the values of P and Q. Now I'm going to give you the answer. I got P to be, you can try it out at home, to be negative 3, and I got Q to be 5. Just a little bit of advice. Because there are two unknowns in your equation, you need to set up two equations. Two unknowns, I need to find P and Q, so I'm going to set up two equations. Your first equation is simple. Remember, this point 1 and negative 3 lies on this graph. Remember, because the tangent touches the graph, so 1 and negative 3 is on that graph, you're literally going to put the negative 3 into the place of y and the 1 into the place of x. That will be your first equation. It is your second equation that you need to think a little bit. Do you know what I did? I said, Eleanor, why did they give you the tangent? Why would they give you this equation? I thought about it a little bit and I said, gradient is equal to, what did we say? Gradient is equal to derivative at specific point, my x is equal to 1. Try that at home. When you work out your derivative and you substitute x equal to 1 and you make it equal to 5 because that is your gradient, you are going to get two beautiful equations and you're going to be able to solve for P and Q. Try it, everybody. When you get home this afternoon and you have a few minutes, see if your P gets to negative 3 and if your Q is equal to 5. You know, another way that you can test it, if you substitute the P equal to negative 3 in here and the Q equal to 5, and you work out this gradient of your tangent, you will get 5. I promise you, you will get 5. Why? Because you used your logic. Can we stop and we tell ourselves, gradient is equal to derivative. Derivative is equal to gradient. That saves you quite a bit in your calculus questions. I'm just going to do one last question here, everybody. And I can see everybody still seems okay. I just got, okay, that one is the same question where the student asked me, what if it doesn't repeat itself? I just want to finish our session with this question. Right, the graph below represents the function of f and g. With f of x, oh my goodness, look at all these variables. Ax cubed plus bx squared plus cx plus d. So this is this graph here. And they gave me no values for a, b, c, and d. I don't have the equation. And this graph here is g of x, and it is equal to 6x minus 6. I can see that's the y-intercept. So everybody, the information that they gave me is that a equals negative 1 and 0 is an x-intercept, and c equal to 3 and 0 is also an x-intercept. Okay? The graph of f has a turning point at a and b. Oh my word. It says that I must show them that A is 2, B is negative 2, C is negative 10, and D is negative 6. So now I look at my graph and I say, okay, I must show them this, so I can't get any other answers besides this. Another way that they could have asked it was just to determine the equation of the graph. So I am going to go, okay, I'm going to start, it's called g of x is equal to. Now, do you remember when we had a parabola? I'm quickly going to do this. And I gave you the x-intercepts of a parabola. We used the equation y equal to a, x minus x1, that's a root, x minus x2. This is a root or an x-intercept. But you are working with a cubic graph. So we're going to use the same method, but we're just going to say y equal to a. I don't know what a is. X minus x1, x minus x2, x minus x3, x3. Matrix, now you're going to tell me, but ma'am, I then don't even have I don't have 3 x-intercepts, and you're absolutely right. I've only got 2 x-intercepts. There's a turning point at that x-intercept. So what can you tell me? You have to answer this. If you have a turning point at your x-intercepts, Matric, what did we say, Matrix? That bracket repeats itself. So I am going to have g of x is equal to a, x, that x-intercept is negative 1, so this becomes plus 1. Repeat that bracket, Matrix, because you have a turning point there. Remember that. And your last one, you're going to put down x minus 3. Now, I would give you some advice by saying don't multiply out your brackets here. Go and sub in a point to find a. Remember, this is y, and you look on your graph. Can't use that again. I've used it already. Can't use that. The only other point on my graph is 0 and negative 6. Substitute 0 in there, 0 in there, and 0 in there. Oh my word, I'm able to find a. That will give you negative 3. Am I correct, everybody? Yes, negative 3a, and a is equal to 2. Take your 2 and just sub it into the place of a. And grade 12, if you now multiply out your brackets, you're going to find, you're going to first multiply out these two brackets. The answer that you get, you're going to multiply it with the x minus 3. And your final equation will be 2x cubed minus 2x squared minus 10x minus 6. There we go. That is how you found that equation. If they give you the turning points, obviously you can't use this formula. If they give you the turning points, what happens at the turning points? Your derivative at a specific point is equal to 0. So I'll first work out the derivative, substitute in the x where the turning point occurs, and make it equal to 0. That is how I would find an equation if the turning points were given in this case. So I would work out the derivative of my equation, whatever they give me, substitute in my 5, make it 0. Derivative, substitute in the 2, and make it equal to 0. A big mistake that students make, they put it equal to 18. But your derivative at your turning point is equal to 0. Matrix, I think that is all the time we have left for this afternoon. But before I go, I would like to inform everybody, if you haven't heard already, that my co-presenter for mathematics, Mr. Faldi Trekoning, sadly passed away on the 13th of July. He had a sudden heart attack. And I know you know him. He's the guy with no hair. Do you remember him? He was always so passionate about mathematics. He did the best PowerPoints ever. And I just want to say that we at the Telematics family, we will miss him dearly. He has made a huge, huge contribution to mathematics as a father, as a teacher, as a colleague. We will miss him dearly. And so I know you remember him. He's taught you so many times on this program, and it's with sadness that we have to inform you of his passing. And so, Matrix, we end of our session on that note, and I hope that you've learned this afternoon and that you enjoyed the session with me. I really, really enjoyed teaching you. Have an awesome afternoon. Remember, hard work breeds success, and never, ever give up trying. If you don't get it right the first time, you just try again. Even the second, third time, you will get it right. It is the hard-working students who get the highest marks these days. Good afternoon, and bye from the Telematics family.